All right, guys, so we are asked to graph and find the inverse of the following function, and we have f of x equals negative log base 4 of x plus 4 plus 2. So you can just graph it. If you've got Desmos, you can just graph it this way and see what it looks like here. Now, I would probably recommend, because you can't always use Desmos, I would recommend trying to use a graphing calculator and doing your log trick. That means you can have your negative. Make sure you go ahead and divide your log base 10 of x plus 4, and then again another log with the base 4, and you can see there that it's starting to match up with the other one. And if you want to see that they are the exact same, you can. So there's your graph. If you're asked to put it on paper, I recommend that you come here and create a table from there of values. This is a little confused because we have two f's, so let's just change that to f1. And now we can see the points are lining up onto f1 of x. You could also change this to this function if you needed to, and it would do the same thing. What you'll notice here is if you're on a piece of paper, it might be really difficult to graph 1.2075. So great thing about this calculator and even your handheld ones is you can start changing these values and getting better looking values. So you don't have to use those decimals. Say you wanted to go back the other way. Let's just take this down a little bit. Make that one 0, make that one -2. And so -3 maybe. You can see maybe you want to go back to -4, see that that's undefined. So that's a bummer, but that also tells me where my asymptote is. Now, remember, logarithms, logs have vertical asymptotes, and it's always in the form x equals. And so you saw before it was that number right there, and it's the number inside of this, right, inside here. So it'll be a -4 because we changed that transformation around. So if I was to graph that, you can see this vertical line here. And let's make it dotted here so you can see a little bit of how it never actually touches it. Say we zoom into a point where we think it's going to touch. The closer we get to these two, the more separation you're going to see between them, right? So they actually never do touch, even though they're super close to each other. All right. So we've kind of done the graphing portion of this log, talked about its vertical asymptote. Well, what about finding the inverse? Remember, first thing about an inverse is that you must switch x and y. So if I went back to that original equation, now instead of it being the negative log right here, negative log base 4 of x, we'll write this out, and Desmos will try and graph it. X equals, as the y value, negative log base 4 parenthesis of y plus 4 plus 2. Now, we don't want to leave it in this form, although that is the exponential graph. It's just written in this form. We want to turn it into the exponential, so we start to solve this. And you'll notice every step of the way, these two graphs are going to line up. So I'm going to get rid of these two and these points. And so every equation that I write from here on out should match up. So this will become x minus 2, because we will subtract this 2 over here, equals the negative log base 4 of y plus 4, and see these two lines match up. The next step of work is going to be to get rid of this negative sign, so we'll divide it over. This will become a negative x, change the sign, plus 2 equals log base 4 of y plus 2. You can see again, not 2, 4. You can see how, again, all of these are the exact same graph. Okay. Into our next line of work, we are going to apply the conversion between a log to an exponential. So that means that this base becomes the base of the exponential. We take it all to the power of this side, so negative x plus 2 and it equals this y plus 4. And if you want to check, it should match up with the previous line. So it does. Almost got y by itself now. So y by itself, we're going to subtract the 4 over. So 4 to the power of negative x plus 2 equals, not equals yet, we'll subtract that 4 over like I stated, and then there's that y. And again, it's all the same. So this was when we switched. This is our final equation because y is by itself. And a lot of times you'll see them written with this little negative 1 of x. And then we can kind of just write all of that out there. Let's see what the error is. F is a function. Try using parentheses. I wonder if it's just that negative 1. Yeah. So, right? Okay. Anyway, the f of x is there. So they're all the same line, and you can see that they all, if I take each piece away, they all line up in the exact same place. Okay, but this is the final